Hi group, it's Mrs. Schaus here. We're ready to take a look at some content from section 2.3. We're going to begin with learning target 2.6, which is on identifying critical points of a function. That means we want to be able to determine intervals where the function is increasing or decreasing and find absolute as well as local extrema. Don't worry if these are pieces of terminology that sound a little new to you or something like that, because we will most certainly explore what those ideas mean. And then we want to be able to use the idea of extrema in a real world situation as well. This next piece on finding the average rate of change will be for our next section, so I'm actually going to bypass that for now. Let's start out with defining what it means for a function to be increasing or decreasing. And I'm going to provide you here with a more formal definition, but I want you to know that really you probably already have a feel for what it means for a function to be increasing. If I were to describe it in just some very basic terms, I would say that it means when we look at the graph from left and working towards the right, that the graph appears to be going upward. The y values are increasing, and that's what we would mean by an increasing function, or at least a portion of it being increasing. To define it, though, let's say that on an interval, and I'm going to name that interval I, this is per what you'd see in your textbook essentially, then if f of x sub 1 is less than f of x sub 2, whenever x sub 1 is less than x sub 2 in the interval I, then the function is increasing. So to draw a little picture to try to make sense of that, if we have a graph, it could be any type of graph, but here's a little picture, and if I were to drop down and call this point x sub 1 and this point here x sub 2, then what I would notice is that this output or function value, that's really our f of x sub 1, that's less than this value here, which is our f of x sub 2, right? Here's our later point x sub 2 as an input value, and our function value or output f of x sub 2 would be right here. And so this f of x sub 1 is less than f of x sub 2. So we can see that it's going upward as we work from left to right. And so we would define a decreasing piece of the function in a similar way. We could say, again, on an interval, and I'll call that interval I, then if f of x sub 1 is greater than f of x sub 2, whenever x sub 1 is less than x sub 2 in the interval I, then the function is decreasing. And once again, I could think about drawing a little picture to make sense of it, and we would see something like the following. If I pick two different values here and I label those x sub 1 and x sub 2, then for this output, the function value, or f of x sub 1, is greater than, bigger than, this output, f of x sub 2. All right, so now what I'd like us to do is to be able to determine where, or in other words, the interval where, the function is increasing or decreasing, and to be able to state that. I'm going to try to come down just a little bit closer so you can see this graph a bit better. There we go. All right, so when I look at this function, and there really should be some arrows on the ends here, and I'll also just go ahead and put them in here while we're working on that. All right, so this function, if I were to start from the leftmost piece that I can see and just go through and trace the function, I can see that it heads upward. That's increasing, right? Then it comes down, decreasing there, and then it heads back up again, so it is increasing. So if I want to state where, move this camera down a little bit, if I want to state where it is increasing, let me write that, increasing, I'm going to use interval notation to denote that, And remember, this starts out by increasing until we get to this point right here. Well, when we say where something is increasing, on which interval that it's increasing, we're talking about the x values. So since this is pointing not only downward, but it's working more to the left, I would say from negative infinity until we get to this point right here, which in an x sense is -2. So from negative infinity to -2, the function is increasing. Then we know that it does take this downturn, but once we get right here, from this point upward, it is increasing again. So I need to know what this is in an x sense, and for now, without the use of our graphing calculator, we're just going to approximate that. So I'm going to say it's at about a half. I actually think it's a little bit bigger than that, but since we don't know the equation and we only have the graph, we'll call that good enough. So I'm going to say the union symbol, another place that it's increasing, is from 1/2 to positive infinity. Okay, and then for the decreasing piece, again, where was the function sort of moving downward here? Well, again, from this point here to this point. Sorry about that bell. There we go. Okay, so from -2 until, what was this point again? We said that it was approximately a half. So in that interval, it would be decreasing. And it's that simple. Okay, in the next piece here, we see more turns sort of happening, change in direction, right? So when we state our increasing and decreasing pieces, there might be a little bit more work to do. So I'm going to write down increasing and decreasing, and we'll find the pieces where that's occurring. So what happens initially? Well, when I start out with my x's that are at most left here, it is initially heading down. So for the decreasing piece, I'm going to say from negative infinity, and it's kind of odd maybe for you to think negative infinity here. I know this is heading upward, but remember the up piece are the y values, and when we're stating these intervals, we're talking about the x values. And the x values are most to the left over here, and so even though this is going up pretty quickly, it is still working its way eventually to the left. So that's negative infinity until we get to this x point here. And again, I'm going to have to approximate it. I think it's a little bit less than -1.5, but let's just call it -1.5 since we, again, aren't using our graphing device just yet. And we don't have an equation to work with. So we'll say negative infinity to -3/2 approximately. And then it goes up for some interval, and then it comes back down. So if I wanted to stay with the decreasing piece, I could go ahead and try to fill in this next spot, but I think I'll just keep working from left to right. So I'm going to say that from this point to this point, it is increasing. That's from -3/2. Again, in an x sense, this is the 0.04, but in an x sense, that's 0. Like I mentioned, from here to here, it is now decreasing again. So I'm going to put in a union symbol here and say that that is from 0 to, what is this point? Well, again, that looks like it's about 1.5, so I'll say +3/2. And then it turns back upward, so I would put a union symbol here and say it is also increasing from 1.5 or 3/2 to positive infinity. So that's how we state where functions are increasing or decreasing. All right, for this next piece, we want to talk about maximum and minimum values. And this connects certainly to the idea of increasing and decreasing, because when a function changes its direction, it's increasing and then starts to decrease, or other way around, decreases and then starts to increase, then that's where a maximum or minimum occurs. It might be what we call a local or relative maximum or minimum, or it could be absolute. Again, if you don't know those, that terminology doesn't seem familiar to you, not a big deal, because we're going to address it here. All right, so when I look at this function, first of all, I think it is important that we understand that if I ask where a maximum or minimum occurs, then I'm talking more about the x value or the point where it occurs. But when I actually ask for the maximum or minimum, I'm talking about the y value. So when I think about the y values on this function and where they are at their greatest or at their lowest, that's what I'm really concerned with in finding these max and min values. All right, let's start out with the minimum pieces, because here I think it'll be a little easier for us to also address this idea of local versus absolute. So I do see some y values. I'm starting with the leftmost again and kind of working my way through the graph. When I'm to the left here, I see the y values coming down, and they get to this point. Do I see them going any lower than that? And the answer is no, right? I don't see them going any lower than that. It turns back up, eventually does come back down, and again gets to this point and heads back upward. Now these both have the same y value. It looks like it's really close to -2. It might be a little bit less than -2. Maybe I'll just call it -2.1 in both cases. But I don't know the exact values without having the equation and using a calculator. So if I'm approximating it here by the graph, that would certainly be fine. So the lowest value, the actual absolute minimum, is -2.1. -2.1. It does occur in two different places. So I could say the minimum is at, and then I could give the points. This is like, again, I'm approximating here. It's about -3/2 and -2.1. And it occurs again at, that's about +3/2 and -2.1. Okay? So the point, or the x value, would be used to describe where the minimum is occurring, but the actual minimum is the y value itself. Absolute in this case because the graph never goes below that y value of -2.1. Okay, as far as the maximum is concerned, now when I look at this graph, if I were to just kind of narrow in on this piece right here, that sort of middle section, I do see that there's sort of a highest, I'm going to call it peak, right? There's like a highest peak there. And where does that occur? It's at the 0.04, but in a y value sense, you would say that the maximum here is at 4. But is it the very highest point on the entire graph? The answer to that is no, because I have these arrows on the end here that indicate that the y values, both here and here, are continuing to go up and up and up, and we never actually reach a true absolute maximum. So this, I'm going to write in here, is a local maximum. And that local maximum is 4, but it occurs at 0.4. Okay, so we do have absolute minimums in this particular problem, but we only have a local maximum. And certainly functions could be, in a position where they have absolute maximum, but just local minimums, right? Or some combination, thereof. I put this little grid here because I wanted you guys to see that in some cases you'll have functions. Now you should recognize this one. This is a cubed function, right? And we do see it change curvature. We're not going to talk about concavity of this function, but that's what's really happening. It's changing curvature here. And so this is neither a highest point or a lowest point, even for a portion of the graph, because the function is increasing, and after this point, it is still increasing, right? Maximum and minimums occur when we're decreasing and we change to increasing, or we're increasing and we change to decreasing, right? That doesn't happen here. We're increasing, still increasing. So this special point right here is called a point of inflection. But not an extremum point. Okay. As far as finding absolute and local, or sometimes we call that relative extrema point. Extrema just means maximums and minimum values, maxima and minima, if we're talking about plural there. Then we can find those in some cases by hand. So for quadratic functions, it might be easier for us to actually find them by hand. But for all of these, the bigger focus in this section is going to be finding those extrema using our graphing devices. If you're ever in a position where you don't have your graphing calculator with you, or maybe the battery's, dying, you haven't gotten to the store or something like that, Desmos, if you just go to, type in, Google Desmos, you will have this nice site pop up for you, and it's a good online option for graphing and relatively easy to use. You would have to probably explore it a bit, but I thought it was a nice time to point that out. We might use Desmos a little bit in the classroom at some point as well. Okay, so minimum and maximum values for quadratics can be found if your equation is in the form y equals, wrote it here, y equals ax squared plus bx plus c, by identifying where the vertex is. And I'm going back really not just to last year, but to Algebra 1 to say, remember that we find the vertex of a quadratic by using this little formula, x equals the opposite of b over twice a. That does only give us the x-coordinate. Once we have the x-coordinate, we plug it into our function so that we can find the actual vertex and determine whether it's a max or min. All right, it looks like I wrote one function here and then changed to a different function down below. Let's not worry about this one. Let's go ahead and work with this one for the moment. Maybe we'll come back to that. All right, so again, thinking about finding the x-coordinate, we want to plug in x equals the opposite of b. So here's our b value. That opposite will be -5 over 2 times an a value of -2. Well, I do have a negative over a negative, so that's going to give me a positive, and it is a positive 5/4. In order to find the y value, I need to evaluate f of 5/4. Let's see what we get there. All right, got some work to do here. This is 25/16 and 25/4 there. So now to kind of clean this up, 2 goes in here once and in here 8 times. Don't forget we still have the negative though, so I've got -25/8. I'm going to need 8s here if I'm going to be able to combine those two, so let me write this as 58. And how many 8s is 6 whole? Well, that would be 8 times 6, or apparently I can't multiply today, 48/6. Okay, so let me just real quickly do a -25 plus 50 would give me 25, and then 25 more, 25 and 48 is 73, so this would be 73/8. Maybe you'd want to write that instead as a mixed number. That's up to you. But again, really, if I wanted to write down the maximum now, I would say the maximum is 73/8, and it happens at the point 5/4, 73/8. Now, how do I know that this was a maximum rather, it did say find the maximum, but how do I know that it's a maximum rather than a minimum? Well, again, using some of our past knowledge about parabolas, what we know is that if the parabola has a negative leading coefficient, I'm not sure about exactly where this thing's at, but what I do know is it opens downward, right? So it makes sense that this would be a maximum or highest point rather than a lowest point, okay? All right, I think for time's sake, I'll move along and we'll do another one of those in class if you need to see it. But again, our focus is really going to be on finding these extrema values graphically. Okay, so we started using our graphing calculator, but we're going to use it a little bit more here to, to try to actually look at the behavior and determine max and min points for these particular functions. So I need you to get the calculator and turn that on. And we're going to go to y equals here and type in x raised to the 3rd power plus 2x squared minus x minus 2. Enter to store that. And I'm going to hit graph. Now when I graph that, I can see that it's changing here, and so there is a maximum. It's a local maximum because this heads up more and more, and again a local minimum since this heads down more and more here. But I don't have a great picture. I could change my window to try to sort of zoom in on that a little bit. Maybe I'll change my values both of x's and y's to being negative and positive 5 respectively, and see if I get a little clearer picture. That looks much nicer, doesn't it? Now in order to calculate those local max and min values, we're going to hit, this is where you need to pay attention to new keystrokes. Second, calculate, and I want to come down to, I want to do the maximum piece first. So I'm going to come down to number 4 and hit enter. And at this point it puts a cursor on the screen and it says, is this a left bound? Meaning, are you to the left of the point that you're interested in? We're not. So I want to take this arrow key and move to the left. Don't move up, even though we are kind of working up as we move to the left. But the left arrow key, and come over to the left side of that. You don't have to be in any specific place, just relatively close to that maximum point that you're concerned with. And then hit enter, and now it'll say right bound. So again, take the cursor, or the arrow key rather, and move the cursor over to the right. Hit enter, and then it'll say, guess. Do you want to know the maximum value that's in between these two values? And the answer is yes, we do. So we hit enter one more time, and then it'll put the cursor on that point and give us a good approximation of where that maximum is. So I'm going to say the maximum here is at the point -1 point. I'm just going to go 1 decimal place out, so -1.5 would be pretty good. And for the actual y value, the maximum itself, the relative maximum or local maximum, that's 0.6. Again, approximately, but it's pretty decent. Okay, let's find this, and maybe I'll also just real quickly write that this is a local max. And now let's find the local min. All right, so I'm going to clear my screen. That takes the cursor away, but I need to go through the same process again. Second, calculate. This time I'm coming down to minimum, however. And even though it says left bound, I'd like to be a little closer to that minimum. I want to move away from this other extreme point. And I'm going to hit enter. Yes, we are to the left of it. Take the cursor and move it to the right. We're to the right of it, so hit enter. Yes, I like the minimum between those 2 points. Notice the little arrows at the top here. So I hit enter one more time, and it tells me it is at 0.2, -2.1. All right, let's take a look at another function together. This time we're talking about a fourth powered function. I'm going to go ahead and go back to my y equals screen, and I'm going to clear out that function and type in my new one. X raised to the 4th power, bring the cursor down out of the exponent, minus 8x raised to the 3rd, again move over, plus 4x minus 20. Now I'd like my window to be back on that standard window, so let me hit zoom and then 6 for standard. That'll take me back to that window that's a little larger, 10 by 10. Oh, what's going on with this guy? I can't really see, can I? I can tell that I need to see what's happening down here, so I should choose a larger a negative y value. It should be more negative in a y sense. So let me go back to my window here, and let's just type in like -40. I have no idea exactly where I need to be, but I know I need to look, kind of deeper down there. Oh, all right, I can see a little something that's happening here, but I'm still just not quite low enough there. So again, in a window sense, maybe I want to go down to like 100. You're kind of guessing here, but guessing with some skill. I knew I needed to look kind of down below. Yeah, still not deep enough there. So let's go ahead and maybe this time I go to -200. What will that do for me here? Still not enough. Keep moving. Still not it'll take you guys some time to play with this, and get these maybe truly where you want them to be. It's not a super easy skill for some functions. So I can finally see it. So I do have an absolute minimum. And in order to find that, I'm going to hit second, calculate, down to minimum here. I want to come closer to that point that I'm interested in. I'm to the left of it. I'm going to hit enter. Move my cursor over so that I'm to the right of it. Hit enter and enter one more time. And I find that absolute minimum occurs at 5 well, it's 9.7, so maybe I should have just said 6.0, whichever. And then here, negative 428.1. Okay, so that's an absolute minimum. But what was happening, up here where I saw some change previously? Let me take my window back to that normal negative 10 to 10 window for just a minute and take a glance at what was happening there. Whoops. Maybe I still wasn't quite low enough there. I better come down a bit more. There we go. Now I can kind of see it. Do you see that the graph does head down, turns back up, and then back down again? So it looks like I have a local minimum and a local maximum. Local minimum and a local maximum at those places. So I would still have to go through the same process. Maybe I'd like to narrow my window here, so I could change my window to look at x's between, let's do -4 and +4 and see if we get a little bit better view. All right. In fact, something I might like to do is trace so that I can kind of see, watch the y values here. They are decreasing, 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 getting smaller, and now I can see them turning back up. So definitely a local minimum sitting there. I'm going to do second, calculate, down to minimum, come to the left of that and hit enter. Watch for the values not just to be going down, but starting to head back up again. And that's when I want to hit enter one more time and then enter again to ask for that local minimum. It is at -0.4, -21. And the local max, oops, what am I doing here? There we go. Lost what I was doing for a moment. Okay, so let me move my cursor. I can see it heading up a little bit. I am to the left of it though. And I will move up. And now I'm to the right of it. Hit enter one more time. And that, I'll redo that one. Not satisfied with that, sorry. Maximum, let me make sure that I'm to the left here. So I see lower values there. I see them going up here and heading back down again. There we go. Let's make sure I have the right spot. There we go. So at 0.4, -18.9, I have my local maximum. All right. Wow, that was a lot of work for us to consider. I want to do one more application, but for time's sake, I think I'm going to go ahead and cut this off, and I'll present this at a later point. Talk to you folks soon.